Hi, I'm John Gauthier, and I'm happy to introduce SyntaxGym, an online platform for targeted evaluation of language models. So language models, to review, are computational models which make predictions about probabilities of words in context. So a language model might predict which word is likely to fill this gap, given, say, this linguistic context. Language models are popular nowadays in NLP as general pre-trained models for building representations of natural language input. And we're interested in the degree to which these models produce human-like representations of natural language input. So a recent paradigm for testing that claim is called targeted syntactic evaluations, or targeted evaluations for short. And in this paradigm, we look at language model prediction behavior on specifically chosen language modeling prediction problems. And they're chosen because we think that they reveal facts about the underlying grammatical knowledge of language models. So in this sentence, we have the farmer near the clerk's blank. And we're interested in the language model's relative preference for a grammatical continuation like knows versus an ungrammatical continuation like no. And the preference there for the grammatical continuation should reveal whether or not the model has extracted the correct knowledge about subject-verb number agreement in English. So in this paradigm, we generally use a metric called surprisal, which is simply the negative log probability of a word in context. So concretely, in this case, we'd say we want the model to have lower surprisal for a grammatical word knows versus an ungrammatical word no. And this paradigm has been pretty productive recently, testing things like subject-verb feature agreement here to things like filler gap constructions. If you're interested in sort of the scientific results in this evaluation paradigm, I highly recommend you check out this paper from my lab, also at this ACL, where we test the relationship between these targeted evaluation results and standard ways to evaluate language models like Perplexity. So despite current progress in this paradigm, we think there's a substantial blocker to continued progress. And that is that designing targeted evaluations requires an uncommon confluence of skills. So to design a good targeted evaluation, you need both the skills of a language scientist to design a controlled experiment which probes some grammatical phenomenon of theoretical interest. But you also need the skills of an NLP researcher to design and implement and test large-scale neural network language models. And that's a pretty uncommon intersection of skills in our community. So SyntaxGym was designed to resolve this problem. We want to allow both communities to do what they're best at, and SyntaxGym will handle the rest. So here's the basic layout of the site. We are going to ask linguists to do what they're good at, to developing experiments which do controlled tests of theoretically relevant grammatical phenomena. And we're asking NLP and machine learning researchers to develop state-of-the-art language models. What SyntaxGym does is it takes these models and automatically evaluates their performance on these experiments, and then provides the results and accompanying visualizations and analyses for easy access. So in short, the goal of SyntaxGym is to make this paradigm of targeted evaluation reproducible, easily accessible, and standardized. So let's jump into a bit about that standardization. The core of SyntaxGym is the test suite. So test suites operationalize a test of some grammatical phenomenon, or rather the knowledge of that grammatical phenomenon. So the core of a test suite is an item. So items are groups of minimally varying sentences according to this grammatical phenomenon. So here we have a sentence, the farmer near the clerks knows many people. And it exists in this condition called match singular, where we have a singular subject and the verb number matches the number of the subject. We have a minimal pair sentence next, called mismatch singular, where the number of the subject mismatches the number of the verb. So items consist of these minimally varying sentences. The sentences are broken into regions. So regions are strings of tokens for which we might be interested in measuring probabilities and surprisals. So the other component of a test suite then is predictions. So predictions are statements of expected relations and surprisals between regions. So this first part of our prediction for this test suite, for example, states that we expect the surprisal in the matrix verb region under the match singular condition to be less than the surprisal in the matrix verb region under the mismatch singular condition. Simply that means we expect the model to assign lower appraisal to the grammatical continuation versus the ungrammatical continuation. And the second part of the prediction states the same expectation for plural subjects and matched or mismatched verbs. So we've collected a lot of these test suites on the SyntaxGym site, and I'll briefly show you those now. So we have over 30 test suites assembled from past research, and they range quite a bit in the average performance of our models that we test. We'll talk about models next. But the test suites range in average performance from something like 15% to something like 95%. This is just a seed set. We intended it to be just a seed set for the site. So we welcome you to submit your own test suites. We've designed a form to easily do this. Say I can create my own test suite here with a certain number of regions, and maybe create my own subject-verb number agreement test. You're also welcome to submit test suites via standard spreadsheet format. So we've done our best to make this available for non-technical users whose skills lie in developing good controlled experiments of grammatical phenomena. So that's the first component of the site, the test suites. And the second component is the models. So we've collected a number of models here, ranging from GPT-2 to a simple LSTM model. And concretely, what we've done is we've taken open source code bases already available for these language models and wrapped them in a simple Docker API. And again, this is just a seed set. So everything is standardized and public. So you're welcome as a language model creator to take your own code base and wrap it using this API. If you submit that wrapped model to our site, we can easily evaluate your model on current and future test suites. So those are the two inputs to the SyntaxGym site, and we can start to see what the SyntaxGym site can show us in terms of results. So here's a high-level analysis of 3 models, GPT-2, recurrent neural network grammars, and vanilla LSTMs on different groups of test suites. So here we have, for example, the agreement test suite, where GPT-2 and RNNGs greatly outperform an LSTM model. We can zoom in a bit more and see that agreement is actually composed of different test suites, and maybe check out this subject-verb number agreement test suite. So we've already seen the basics of this test suite. We can check out the content here, or the predictions. These are broken up into the 2 component parts of the prediction that we saw before. One for checking the corrective verb preference for a plural subject, and one checking for a singular subject. And next we can see for the models currently on the site, the distribution of prediction accuracies for those available models. And we see that actually models do quite a bit better on prediction 2, that is the verb preference for a singular verb, than they do for prediction 1, which is in line with what we already know in the literature about a plural bias in subject-verb number agreement in English language models. We can drill a bit deeper next and see per model performance on each of these predictions. So here we see that most models degrade on prediction 1 with the plural subject. We can go even a bit deeper and look at the raw data. So here is GPT-2's performance on subject-verb number agreement. And here we're looking at the raw appraisal data for each region of the test suite. And of course, the critical region to be measured in this test suite is the verb. So all of this raw data that is behind these visualizations is, of course, available for download on the site. And you're welcome to use the site just by taking that data and running your own analyses. We expect as people submit test suites and models, we'll just get a richer and richer collection of data to be analyzed. So with the remaining time, I'd like to present a few tools that we think are of independent value to the community that we developed in the process of making this site. So the first is called LMZoo. I'll jump back to slides. So LMZoo is both a command line tool and a Python API that provides black box access to state-of-the-art language models. So you can do everything from as simple as pre-processing text according to the standards of a model, to extracting word-level predictive distributions from a language model. It's available now via pip. You can install it right now using this pip command. So here's a bit of an example usage. LMZoo list gives you a list of the currently available public models. As I mentioned before, we wrapped quite a few existing open source language models using our Docker API. If you're a language model creator, you're welcome to check out our API documentation and wrap your own model and submit it to us. And your model will instantly be available to the community for use in these analyses and others. So we can do things like extract word-level surprisals for this text file that we input from GRNN, a popular LSTM model in this evaluation paradigm, or do more thorough things like get the entire predictive distribution for a model in HDF5 format. I'll just point out briefly that we have lots of documentation about LMZoo independently from SyntaxGym. You're welcome to check this out, and if you're a language model creator, we encourage you to contribute your own model so that it can be evaluated on our platform and possibly others. The second tool we publish is called SyntaxGym, which is simply an offline version of what's available on the site. So it's, again, both a command line tool and a Python API, and it allows for easy targeted evaluation of language models. Again, it's available as a pip package. So using a standard representation of the test suites like we described before, we have here, say, the prediction and the individual items encoded in JSON. You can, say, evaluate from the command line the performance of a model on this new test suite. So this animation should restart in a second. We can now run on, say, GPT-2, our new test suite, and find out there are 2 items. We get one of them right, one of them wrong. So separately from the site, you're welcome to download this tool and run your own evaluations on your own machines. So that's SyntaxGym. I welcome you to check out the site at syntaxgym.org. Everything is open source. You're welcome to contribute your own language models, again, using our Docker API, or your own targeted evaluations. You're also welcome to just visit the site and check out the results and run your own analyses to better understand the language derived within these language models. So with that, I'd like to thank my collaborators and our funding sources, and thank you for your attention.